Logarithm limitations and graphing. And when I talk about logarithm limitations, I'm talking about limitations on your calculator. As I've said in other videos, one of the things that's important when using these types of calculators, or really any type of technology, is not only understanding what they can do, but also being aware of what they can't do. Because sometimes we'll think that they can do things that they can't, and therefore we can either misinterpret results or just get frustrated because we're not getting what we want. What I have here are two graphs that I'd like to create on the calculator. We're going to do each one separately. And this is going to point out what can be a somewhat severe limitation in some ways for the calculator with regard to logarithms. But if you pay close attention to how you're working with logarithms, it turns out that it doesn't have to be a big limitation, and it's something that is fairly easily worked around in a lot of situations. We're not going to get really deep into this, but it is something that I want to at least make you aware of here. So let's take a look here at example 1, where we're asked to graph y is equal to the natural log of x. All right, so let's go into our y equals menu on the calculator, and we'll tell it that we want to graph the natural log of x. Now the natural log is the log base e, and we get that on the calculator by pressing the ln button. The log button just above it is for the log base 10 function. So we'll press natural log, then we'll press x. You'll notice that it opened a parenthesis when we pressed the ln key. We'll close that parenthesis, and we'll press enter. And now I'm just going to plot that in a standard window. So I'm going to press zoom and 6. And we get the graph of the natural log of x. Now, the function, logarithmic functions in general, pass through the point 1, 0 on the graph, and you can see that happening here on this graph, where it crosses the x-intercept. We know that the domain of one of these functions is positive numbers, that is, numbers greater than 0. This function will never touch or cross the y-axis. We know the range is all real numbers, so we can get anything from negative infinity to positive infinity in the range. And the function is very close to the y-axis, but just to the right of it for a long time. It grows very quickly for numbers, values of x very close to 0. But as our values of x get larger, the function tends to grow more and more slowly. Though if you do go out far enough on the x-axis, you can get up to very large values on the y-axis as well. All right. We can press the trace key and move around. We can pick specific values. We can go in and look at a table. We can do just about anything we want here, taking a look at this natural log function. We could replace the ln with log and do this for the base 10 logarithm, and we would still have lots of options available to us. But you'll notice that the calculator only has two logarithm keys, the base 10 log key and the base e log key. What do we do if we have something like example 2 here, where we want to graph y is equal to the log base 3 of x? That's a non-standard base and one that our calculator doesn't handle. All right. Well, there are a couple of different things we can do, and here's the first one that I'm going to show you. Let's remember that we can take y is equal to the log base 3 of x, and we can convert that to an equivalent exponential expression. All right. So I'm going to take this y is equal to log base 3 of x here. I'm going to copy it, and I'm going to move it down here. And I'm going to go in and edit this for a moment. And we'll see if we can't convert this into an equivalent exponential expression. This is part of why we make such a big deal when teaching logarithms about being able to make the conversion between logarithmic equations and exponential equations. It's a pretty important and actually pretty powerful idea that allows us to do things that we might not otherwise be able to easily do. All right, it doesn't look like this is coming up very quickly here. But I will remind you verbally that what we have here when we convert this to an exponential equation is 3 to the y power is equal to x. All right. So what kind of happens is we flip things around. In logarithmic form, we pick values of x and get values of y back. When we flip it around and look at the exponential form, it's easier to give values of y and get values of x back. All right, so what we can do is we can take that exponential equation and we can play with that. So let's go into the y equals menu here. Let's clear out ln of x, and let's type in 3 to the x. All right, so I'm going to type 3 here, and to the x power, oops, and then we'll press enter. All right, my editing finally came up over here on the other screen, so I'm going to take care of this here real quickly. I want to put in an arrow here to show that this is equivalent in either direction. And what I want to do is type here what we just said, that x is equal to 3 to the y power. And I'll exit out of that and get that back into my document here. So what we're doing here is, even though we're typing in 3 to the x, because that's what the calculator wants, we're going to be thinking of things the way it's written here in this Word document. And I'll explain more about that as we go along. Now, I don't want to look at the graph of this. What I do is I want to go and look at a table. So we're going to press the second key and the window key, which has the table setup menu. All right. And I'm going to pick some values here. I'm going to say, let's start at maybe -3. And I'm going to have it increase by 1. And I'm also going to set the independent to auto and the dependent both to auto. So highlight auto if you're on ask, and press auto if it's already dark on auto. You're in good shape. So this is going to start with -3, and it's going to increase by 1. And the calculator is going to do this automatically. To look at this table, we're going to press second and the graph key, which is the table key. And we'll get this here that'll pop up. And what it tells us is, for our exponential equation, if we plug -3 into it, we get 0.03704 out. If we plug -2 in, we get 0.1 repeating out. Put -1 in, get 0.3 repeating out, etc. If we want to graph this log, notice that the roles of the two variables are switched. So to create a graph of the log function, what we actually would do is treat this y value here as the x value, and the x column is the y column. So we would actually graph the point 0.037, comma, -3. We'd graph the point 0.1 repeating, comma, -2, 0.3 repeating, comma, -1, 1, comma, 0, 3, comma, 1, 9, comma, 2, 27, comma, 3, etc. All right. So here's one way to go about graphing a logarithmic function when you have a base that's not 10 or e. And that is, find the equivalent exponential expression, and then set up a table of values for that, x and y, and then reverse those values. And that will give you the value, give you a graph of the log. All right, this is what's called an inverse relationship between these functions. Every logarithmic function has an inversely related exponential function. Every exponential function has an inverse function that is a logarithmic function. All right. Now here's a slightly different way to at least get a picture of what's going on. I'm going to press second and quit. All right, and if we go into the draw menu, all right, under draw, if you cursor down a few options here, we'll eventually get to option 8, which is draw INV, which means draw inverse. All right, so if we choose option 8, we need to tell it what we want to draw the inverse of. And if you remember, we're going to press the variables key. We're going to cursor to y variables submenu at the top. We're going to tell it we want the function y variables, because that's all we ever do is work with functions. And then we want y1, because that's where we put 3 to the x. And we want the inverse graph of that. So I'm going to press enter, and the calculator will graph for me. Both things, I believe, will come up. Well, let's see exactly what we end up with here. We expect 3 to the x to be a graph that comes shallow on the left and then picks up and grows very steep very quickly. That's the first thing that we're seeing here. So that's the exponential function, but that's not what we're looking for. We're looking for the logarithmic function, and that's the inverse. So the calculator is all it's really doing is taking all those xy points for the exponential function, and it's flipping them around, and it's treating them as yx, plotting them as y comma x kind of coordinates to get that logarithm. There's a picture of that logarithmic function. All right. So to actually plot that on paper, though, the table helps to figure out exactly what those points are. But here are a couple of different ways of looking at things, graphing logarithms. And again, one of the main points of this is to show to you that there are limitations to the logarithm with the calculator, and that's because there are only two bases available through the calculator. But we can work around and find out ways to get at other things if we understand what it is we're working with and understand that relationship between logarithms and exponentials.